Hi! Welcome again everyone. I'm Louie Ubani, your 4th year CE discussant for today's topic. This is my presentation for the course subject CECOM 2. The topic that I will be talking about will be the basics, and it will be very easy to understand if you listen attentively. The topic that was assigned for me is the flow nets, one of the topics studied under the soil mechanics. Bear with me as I introduce to all of you the schemes and related information of the flow net. Let's define each word first that constitutes our topic. According to Merriam-Webster, net is an open meshed fabric, twisted, knotted, or woven together at regular intervals used for an entrapping device or situation. As you can see, net is a structure that is interwoven. They are crisscrossing each other. They form of some kind of entrapping, habang ang flow naman ay to issue or move in a stream, to proceed smoothly and readily. Ang flow ay isang smooth like movement. So in layman's term, net is lambat at ang flow ay ang agos. The flow net's definition. Now that we know the meaning behind each constituent word, let's delve into its definition. According to my research, the flow net's definition is a graphical representation of flow of water through a soil mass. It is a curvilinear net formed by the combination of flow lines and equipotential lines. Flow net ay mapoform lang through the combination of FL or flow lines and EL or equipotential lines, which I will be discussing later on. Flow net is the flow or agos ng tubig papasok sa flow, or ang flow net is the flow or agos ng tubig papasok sa soil mass as a graphical representation. So, flow lines represents the path of flow along which the water will seep through the soil. So as the water seeps underground, yung line that represents the path is called a flow line. Equipotential lines are formed by connecting the points of equal total head, wherein ang EL or ang equipotential line ay ang line that constitutes the points ng mga equal total heads. Another technical definition, it is a graphical representation of how the hydraulic energy is dissipated as water flows through a previous medium. In the field, under sheet piles, under dams, and under masonry structures, flow is not 1D, it may be 2D or 3D. Flow net is a representation that cannot be made in 1D or one-dimensional. It must be either 2D for calculations or 3-dimensional for graphical representation. The flow net analysis. Here, we will be taking up an in-depth basic introduction and analysis of how a flow of water acts under and how flow net is applied. Let's start with a soil mass. A soil mass is a huge collection of small particles called a soil grain. These soil grains, when depositing in a soil mass, encloses empty spaces between them, which we call voids. And as the water poured at the soil mass, of course, yung water will manage to seep into underground through the gaps na tinatawag na natin voids. The water available under the ground moves inside the soil through these voids from the region of high head to a low head. Yung phenomenon naman of flow of water or movement of water through the soil is what we call a seepage. The hydraulic head is the amount of mechanical energy or liquid pressure available at any point in the water above dito. So as an engineer, our aim is to analyze the flow of water inside the soil and try to obtain solutions to the problem. We're going to analyze and brainstorm to obtain a solution. One such problem is to estimate the quantity of water percolating via seepage through the soil under the dam. To solve such problems and to analyze multidimensional flow in the soil, we make use of a concept called a flow net. How do we visualize a flow net? Let's carry on. Para ma-understand natin yung flow net, let's begin with analyzing one-dimension flow before jumping into a multi-dimensional space. Let us consider a soil sample of length L and put it into a glass cylinder. So yung green lines na represents natin is the soil sample, which is in a length of a capital letter L. We attach the top of the cylinder with a water source and let the water flow through the soil and let it exit from the bottom. We also attach a few piezometers at different depths. So for most people, piezometers is either a device used to measure a liquid pressure in a system by measuring the height to which a column of the liquid rises against gravity, or which measures the pressure of groundwater at a specific point. We can observe the flow of water occurs vertically down, we also attach na-attach na nga natin yung mga piezometers at different depths. We also observe the flow of water occurs vertically downward under a head difference of, say, the lowercase letter h. Ayun. Any water particle that enters into soil at its top moves vertically downward, and the path taken by the water particle can be represented by a line called a flow line. Similarly, many particles will flow vertically downward and there will be an infinite number of flow lines. Of course, medyo mahirap pag madami. These flow lines are what we call streamlines. We can observe that at any level in the soil sample of total head is the same for all the points lying in that plane. So we can draw a line connecting all the points of equal head. Similarly, at different levels, such lines of equal heads can be drawn. These lines are known as an equipotential lines. All the points on an equipotential lines have the same energy. Both of these lines, the flow lines and the equipotential lines, are crossing each other at right angles, or what we know as orthogonal to each other. We can see these lines form a kind of net, and this net is what we call a flow net. So as the idea suggested, a flow net gives a pictorial representation of the path taken by water particles and the head variations along the path. This is a very simple flow net, and it is for a unidirectional flow in soil. But for multidimensional flow naman, the flow net may be very complex. And of course, we have several assumptions made because of that idea. And that is, a soil mass is fully saturated, the soil is homogeneous and isotrophic, and soil grains and water are incompressible. The flow net methods. After the analysis, let's continue to delve into the different methods of flow net, or how a flow net is utilized. We have 5 main methods, I think, to construct a flow net. One of these 5 methods will be an in-depth discussed, or will be a topic which will be in-depth discussed later. So we have analytical method, graphical method, electrical flow analogy, capillary flow analogy, and sand model. Analytical method. Analytical method of obtaining a flow net for a flow of water in a soil mass is a mathematical solution to an equation that is obtained by the flow of conditions. It can be used in relatively simple cases of flow, where the boundary conditions are known and can be expressed by equations. In analytical method, Laplace equation is found out by using the mathematical equations possible for simple problems. The graphical method. This is the most commonly used method of flow net construction because it is easy and provides nearly accurate results. This method is one of the solutions to the Laplace equation. Also, some reasons why graphical method is because it is the most convenient and least expensive. It is constructed through intensive trial and error procedure. Simplest and the quickest method, since it includes trial and error proceedings, practice is required for achieving accurate results. And before commencing the calculations, the available published flow nets must be studied and duly analyzed so as to get a rough idea of the nature of the flow net. The electrical flow analogy. This method is based on the fact that the flow of fluid and flow of electricity through a conductor are analogous. This method is only for a practical method of drawing a flow net for a particular set of boundaries. It uses the similarity between the Darcy's law and the Ohm's law, and through the water medium, salt is added and currents are allowed to pass based on the current flow pattern, and thus flow net is constructed. The capillary flow analogy, or the capillary flow analogy. Model of the earth dam is placed between two glass plates and a head of water would be maintained on both sides. Water is allowed to flow and some dye is added to water and the path followed by dye is observed. Based on that, flow net would be constructed. The sand model. This is a physical model of the path that water particles take through soil. Estimating hydraulic conductivity for several soil configurations, this demonstrates Darcy's law with a physical groundwater model. The graphical methods of flow net construction. Among the 5 flow net methods, I was also tasked to discuss the graphical methods of flow net construction, the one being the accurate and the less expensive methods. Let's take a soil mass of some thickness and it lies upon an impermeable strata. A sheet pile is driven into the soil up to some depth. The sheet has water in it on one side of depth capital D and on the other side the small capital D, or small letter D rather. We can see that there is an imbalance of head on the different sides of sheet pile, so the water will flow from high head to low head. But the water cannot pass through this sheet pile, so flow will take place through seepage via soil below. So let us consider naman a water molecule enters the soil at some point on the upstream surface, goes below the tip of the driven face or the driven sheet and ends up at some point on the downstream surface. Yung flow path na assumed by the water molecule is what we know as flow lines. So yan yung flow of water in the soil, and the path that is taking on is what we call a flow lines. Similarly, many particles will leave the upstream and reach the downstream, forming different flow lines. Note that each flow lines begins from the upstream surface, which is at the pressure gamma sub W capital D, and travels through the soil, constantly losing its energy, and terminates at the downstream surface, which is at pressure gamma sub W small capital D, small letter D. So we can pick up certain points on the different flow lines naman where total energy loss is equal, or we can say na yung points ay same energy level. When we join such points together, the lines formed is an equipotential lines naman. And as you can see, there is a net-like structure and we can see we have received our flow net. Yung space naman between two adjacent flow nets, two adjacent flow lines rather, is what we call a flow path or a flow channel. And yung area naman enclosed between any two adjacent flow lines and adjacent equipotential lines is called a flow field. We should remember that in a flow net, we can draw many possible flow lines and equipotential lines. Kaso, it is very inconvenient to draw too many of these lines, and secondly, drawing too many lines does not increase the accuracy of the calculations, so only 4 or 5 flow channels are sufficient. In constructing naman a flow net through graphical methods, we should remember these properties. The angle po of intersection between each flow lines and ELs must be 90 degrees or they are orthogonal to each other. Two flow lines naman, or it's either two equipotential lines, can never cross each other. Equal quantity of seepage occurs in each flow channel. Head loss is the same between two adjacent equipotential lines. Flow nets are drawn based on the boundary conditions only. They are independent of the permeability of soil and the head causing flow. And flow field should be in square form. Also, either flow lines or equipotential lines are smoothly drawn curves. The flow net formulas and applications. Here, I'm going to talk about the formula under flow net observation and its simple basic applications. So we have our formulas. Rate of seepage loss denoted by uppercase letter Q, seepage pressure denoted by the uppercase letter P with a subscript of S, uplift pressure denoted by uppercase letter P with a subscript of letter U, and exit gradient represented or denoted by the lowercase letter I with a subscript word exit. The rate of seepage loss. Using flow net, the rate of seepage loss or seepage quantity can be determined using the below expression. Q or capital Q is equals to K times the capital H times the quantity of N sub F divided by N sub D, where K represents the coefficients of permeability, the uppercase letter H represents the head causing flow, the capital letter N subscript of F represents the number of flow lines, at yung N subscript of D represents the number of equipotential lines. The seepage pressure. Seepage pressure at any point is determined by using the below mentioned formula, denoted by the capital letter P sub S is equals to gamma sub W multiplied by H, in which the gamma sub W represents the unit weight of the water and yung small letter H naman represents the hydraulic potential after N, in where H, small letter H, is equals to the capital letter H minus N multiplied by delta H, wherein the delta H is the potential drop or drop between two adjacent EL. The uplift pressure. It is denoted, or the uplift pressure at any point within the soil mass can be found using the under-mentioned formula. It is also called the hydrostatic pressure. The formula is equals to the gamma sub W multiplied by H sub W, in which again the gamma sub W represents the unit weight of water and yung H sub W naman represents the piezometric head or the pressure head, in which if you want to find the piezometric head or yung pressure head, it is only the total head minus or subtract by the elevation head. Next is the exit gradient. The exit gradient is the hydraulic gradient at the downstream end of the flow line where seepage water from the soil mass joins with free water at the downstream. It can be expressed as it is equals the change in H divided by change in L, in which delta H represents the potential drop or drop between two adjacent equipotential lines, and yung delta L naman represents the length of flow field. In flow net application, through flow net, we can apply this to any calculations of uplift pressure. It could also any problems pertaining to exit gradient or piping, also for heaving and or water pressure. The flow net sample problems. Okay, let's practice to further know if we really understand the basics of flow net. So we have a question. The section through a dam is shown in the figure. Determine the quantity of seepage under the dam. The coefficient of permeability of the foundation soil is 2.5 times 10 raised to negative 5 meters per second. So, Upon observing our graph, we have a given, and also upon observing our problems, or the question rather, we have a given of K, or the coefficient of permeability, which is 2.5 times 10 raised to negative 5 meters per second. Also, we have our H, which we observe in our graph, 5 meter coming from the right side and 1 meter coming from the left side, which we could come up with 4 meters. Also, the number of flow lines, which has 4, and the number of EL, or equipotential lines, which is 15. With that given, of course, we could formulate our formula na yung hinahanap doon sa question is yung quantity of seepage. So we're going to use the seepage, or the rate of seepage loss. With that given, let's find our Q. Let's input the givens and tinkering with our calculations. Q is equals to 2.5 times 10 raised to negative 5 multiplied by 4 multiplied by the quantity of 4 divided by 15. Therefore, our Q would become 2.667 times 10 raised to negative 5 cubic meters per second. So kindly pause na lang to check if our answer is correct. That Q represents the per meter. So every meter, there is a 2.667 times 10 raised to negative 5 cubic meters per second seepage loss. And that's it. Hopefully, I explained to all of you a decent understanding of what a flow net is. Thank you for listening, and if you have any questions in mind, you can check these references that I used to make this discussion as easy as possible. Kindly pause if you want to know more about flow nets. And again, thank you for being with me up until the very end. Have a great day ahead po. Thank you again.